right. Good morning, everyone. You all made it. Final day of DevOps. How's your energy level still doing? High, low, whoa, whoa, okay. Maybe the Joker had anything to do with it. But today, as the Joker yesterday, we're gonna make some music, maybe some more fun music. So let me try to get you into the weekend vibe and make some music all together. All right. Who am I? I'm Jan Van Wassenhov. I'm a lead architect at Soprasteria, Belix. And what's in the name? What's an architect? We all know architects make other people, other smarter people do fun things. We're only there to help them, to encourage them, to coach them. But also, I'm the creator of the Scrum programming language. Not the topic of today, but whenever you feel like checking it out, just go ahead. Just check out the code, launch a program, and you can actually say you're a real Scrum Master programmer. So, a real one. Also, you can find me on Instagram and SoundCloud, because we're gonna make some music today. We're gonna make some fun. So you can find me on SoundCloud or also on my blog, mightyjohn.com. I got two pictures of me over there, not by coincidence, but pictures of me at a concert with the kids enjoying music, because I love music and I'm quite eclectic. It goes from punk rock to electronical, EDM, all sorts of music. But I never get to play music myself. I know how to hold a guitar, I can play some chords, but that's about it. There's my boy over there, the guy can drum. There's my wife, who can sing. She can sing really well. I'm scoring points now because it's coming on YouTube, so that helps. But also, she knows how to play the piano, the org, and I'm still left there without playing any music, without playing any instrument. And I do want to have the same feeling of creating music, but I just didn't know how to do it. But then I came up with an idea, and you know, Jan, you're a coder, you're a developer, so why can't we do anything with coding music? And that's when I came up with something else. So it's about over a year ago I came up with the idea, wouldn't it be fun if there's a lot of fuss about AI, we got AI. From the past, I know already Sonic Pi, which is quite interesting, you can code music in it. And wouldn't it be nice to combine it to have this whole creative process of creating music on your own? And that's when I came up with MusicAgent, actually the bridge between code and melody, using AI to create some new music, new songs. And now I can actually say I got my own band. So meet the band, this is the band. We got John on the keys and on the guitar. You know Ringo, he's on the drums. We got George over there, also on the guitar. Paul on the bass. And oh yeah, there's Jeff. Jeff is over there. Jeff is also playing some keys, he comes in between. They're still training. They're not that good yet, but we're helping them out. They're coming there. But from time to time, they tend to hallucinate. They tend to make some errors, and yeah, then they forget to attach their boxes, their guitars. But yeah, we came a long way. We're almost there. So, MusicAgent. It's a homegrown project. The main coding is done in Python. There's also quite some Ruby code, so because of Sonic Pi, of course. It's open source, it's available on GitHub. You can all download it, you can all use it for free, just for you. It's mainly based on LLM and image model generation. So it's also using the OpenAI API and LangChain for integration. So currently it's only using OpenAI, but you can attach it to any other model if you'd like, or API that's available, of course. But in the end, it's capable of publishing an actual complete new song. It comes even with a recording, but it creates a Sonic Pi song code. It also creates a complete recording. And it even comes with an album cover or a booklet where you have the song lyrics, where you have the complete instructions for the instruments, the arrangements, how the song should be played. But now you might be thinking, okay, you're using LLM, you're using image model generation, but isn't there something more simpler than that, like maybe text-to-speech, Bark, for instance? Okay, I couldn't talk about making music with AI without mentioning Bark, for instance, as a text-to-speech model. Because, yeah, it sounds easy. You got tools today like Suno, Udio, who can come up with some music, who can create easily music for you. Why not using them? That's also a possibility, yes, of course. But the thing is, with those type of models, those type of services, they only offer you limited control. You cannot fine-tune specific elements in the song. You cannot tell, I don't like this bass line. I would like another tune at the refrain or the verse. I want to change small, subtle things in the song. It's not possible. There's also the point of quality. It doesn't offer you the same quality as a real musician would expect from a song. The output is never as good, and you cannot easily reproduce it. Also, it contains simple structures. When you want to apply some more complex structures to your song, think of jazz or think of any rock anthems that take quite a long way, those metal songs, for instance, they cannot really cope with it. They really struggle creating those structures. Also think and in a way, they will start sounding more and more average, those songs. Think of the anthem of Devox. You also heard it in the opening keynote. It doesn't take you long in Suno or Udio to come up with a similar song, similar sound of that song. So more and more, they're all trained on the same data, and in the end, it comes up with more and more of the same. And that's quite of a limitation. While when we combine Sonic Pi and generative AI, and Sonic Pi, it allows you to code your music, you're in control. You can control the composition of your song, you can make it more complex, you can change the structure. Even after it's been generated, you can still change the instruments, the sequence, the arrangement. So it allows you to incorporate more complex structures into your song and really, even in real time, edit the song while you're listening to it. Also, in terms of sustainability, it has a lower energy footprint in regards to those text-to-speech models, because we're only using a simple LLM or only using a simple image generation model. But unfortunately, currently, there's no singing involved. Maybe in my case, that might be a good thing, but yeah, currently no singing yet. So, we're using Sonic Pi. Anyone familiar with Sonic Pi? Some might have heard of it, okay. Sonic Pi, originally created by Sam Aaron. And his main intention was to create something for the kids to start programming, to learn how to program and to easily start programming. It actually features a real-life coding environment, so when playing music, when coding music, it can even change and you can adapt along the way while you're coding. The music will change, you can add a beat, you can add an additional loop, additional samples, and you can play along. It works cross-platform. The Pi in the name comes from Raspberry Pi, because that's the original platform it's started on. Sonic, of course, for the sound involved with it. So, it comes with a real basic syntax, so it's actually quite easy to code, to develop in Sonic Pi, and also quite understandable. So what you see, what you read, you immediately get an idea about it, what it will do, how it will sound like. So plays a note. When sleep, okay, you can add a pause in between some beats. And when looping, okay, then you'll start repeating the beats. Also, the use of samples can help you introduce even spoken or singing within the songs. So, let me quickly show you a bit of Sonic Pi. So just to give you an idea for those who are new.
Eat. Sleep.
Okay. So this is the Sonic Pi IDE. I always love it when you click the help button. It tells you, hi, welcome friend, you're welcome to Sonic Pi. But it comes with a clear help, lots of IDs also. But just to give you a quick idea, quick intro to Sonic Pi, how easy it is to set up a new song. So we're going to start with a simple beat. So I have a loop on a beat with a sample I've chosen, and it gives you something like this. So nothing much to code, quite readable. We all see what's happening. So that's one beat. Let's add another drum. Gives you something like this. Okay, but now we got our basic beat, we got our background drum bass. Let's add another bass line and another melody, and it comes up with. Okay, important to notice. You notice already the type of sounds. It's an electronical sound. So currently today, Sonic Pi is quite limited in terms of synths, in terms of samples to be used. So they all have a quite a electronical sound. That's also important when thinking of creating a new song. You'll always have that electronical basis within your song, but it doesn't block you from creating quite some interesting new stuff. This was a simple beat, simple melody. You can easily play songs that are quite familiar, that you know. For instance, this one you'll most probably know. And it simply uses a simple power chord progression, this one. But it can become more complex, and then you get something like this. Anyone recognize this one? Which was it? It's a Daft Punk. It was aerodynamic from Daft Punk. So that's when using samples, when creating, adding more features to it. That's actually what you can do. What Sonic Pi is capable of doing. So we can go quite a long way. So let me get back to the presentation. Actually, while doing this, it also started a new wave, a new style of music, which is also called algo rave. And
Eat. Sleep. Algorithm. Repeat.
so it just didn't stop with programming for kids. It continued to, it started a complete new wave, a complete new sound of music, where people are programming, coding live, and creating music. But we're gonna take it one step beyond today. Okay, we're gonna create a song. So creating a song, also this was quite new for me. I don't know, are there any musicians in the room? Some? Okay, then you might know this a lot better than I do. I had to learn it by heart. But when writing a new song and creating a new song, it comes with a lot of steps. You get the songwriting, you have to create an initial melody and create some, you have to write your lyrics to create your song. Then you have to think of the arrangement. You can do it also in another order, of course. You can first come up with a melody, but you got to structure your song. You got to think of, okay, when will I play which instrument and which will I play in parallel? You got to actually capture the performance. You got to make a recording, and there's the aftermath. There's the mixing. There's the mastering. Are there any? Do we need to fade in? Do we need to fade out? Do we have some gaps in between? Do we want to leave them out? And in the end, we want to publish our song. We want to create a nice album cover to make it publicly available to everyone, so they can listen to your song and they can use it. But so, main question is, how do we do this in MusicAgent? Well, actually quite simple.
Hallelujah.
We pray to the AI gods and hope they help us. Not directly like that, but sometimes it is a bit like that. Just a quick throwback. Over more than a year ago, we started to working a lot with foundational models. And we all know, now we know today, those foundational models, there are big machine learning models based on lots of unstructured data, like text, voice, even images, which we trained and then allow us to answer simple questions and even more complex questions. So they can even create AI art, they can come up with some intelligence and even analyze photos and give us an answer based on that. But they cannot efficiently take multiple step tasks. So they need guidance, they need monitoring. Think of when you're chatting with ChatGPT, you ask him to write a mail. In the beginning, most of the times it's quite polite, but that's not your way how you address to someone in your mail. So you give him some more context, you guide him in the right direction. And although it's a good tool, but we need to guide him a bit more. And that's where autonomous agents come along. They actually create a new dimension where we saw a rise in answering answers on complexity level. When we look at GPT-2, GPT-3, GPT-4, the amount of complexity on one single question they can answer is always getting higher, getting better, but still there's a chain of thought. We ask him a question, we get a response in return, and then we help him continuously directing in the right direction. This chain of thought is something that we had to do before, but then over more than a year ago, autonomous agents came along, actually tackling this complete problem space, where we came from having a question, a direct response, we started having a bigger problem by guiding him in the right direction and doing this automatically by using these agents. We could broaden the space, we could solve this larger problem space and tackle these problems. And that's why we also call them slow thinking, because they take more time, but they do it in multiple steps to come to a solution of the problem. So, autonomous agents, they break those big complex tasks, they break it in smaller chunks, and then we can actually use, for instance, an LLM, but it can also be an image generation model, can be a text-to-speech model, could be something else, to separate all our different problems and store the result in subsequent steps. So every result of every step is taken into account, is being stored and taking along along the way, it's taken with them. So it provides them the capability of handling those complex tasks which you couldn't do before, where you had to ask an LLM, for instance. You asked him a question, you got a solution for your problem. Well, it wasn't quite the response you were expecting, and you guided them in the right way. So, taking it one step further, we had one autonomous agent that could solve that complex task for you, but let's take it one step further and introduce a MAS. And with the MAS, for the Belgian people in the room, this is not the MAS is over there, about a few kilometers from here. But with a MAS, I mean multiple autonomous agents. So think of having all those agents. They all have a separate task. They all live in a separate context. And they can have their own focus and mission on to achieve their own individual task. But combining them, they will also come with a solution for a common goal. So taking it in the context of MusicAgent, how does it help us? Well, within MusicAgent, we saw the different steps from song creation, in the process of song creation. It will help us creating a melody, harmony, and rhythm, where each agent has his own task, his own specific task, and can focus on, for in the end, to come to a complete composition of a song. So, in terms of MusicAgents, these are the type of roles that we will be introducing. We'll have an artist, we'll have a composer, we have a songwriter, but quite particular, there's a Sonic Pi coder and a reviewer and also a Sonic Pi mix engineer. So yeah, there are some particular adjustments we made for MusicAgent just to make it work in the end. So some technical challenges, as I already said. Sonic Pi has some limitation because it all mostly comes with an electronic sound, so we have to play along with it. So we have to make use of it. The initial project was set up as a prompt engineering, so it was more of a test on, okay, how fast can we do something from prompt engineering without even knowing Python before? How can we easily create a new project? Another point to tackle was the LLM input and output for the agent. How can we make sure that when our agents start a conversation, that we set the context right, that we are promoting the right answers? And there's also the bigger problem of token limitation. So at some point it comes to an end, and we have to limit also our conversations. We have the conversations in between agents, but then we also have to chain all those steps from creating and conceptualization to songwriting to actually coming up with a real song, with a real output song. So putting them in the right order and combining the right task at the right point was also quite challenging. And of course, the type of model. So as we're using mostly OpenAI, I mostly use the OpenAI models. Having a new model doesn't necessarily mean it's being improved. At first, the results were better with a GPT 3.5 Turbo than a GPT 4, where today I would say GPT-4o Mini gave a lot better results with MusicAgent. So let's start with creating a song. So how does it actually work? We start from a user input, where MusicAgent will be asking you some questions. So what's the style of music you prefer? So if you prefer rock or electro or drum and bass, we cannot fully reproduce the sound within Sonic Pi, but those type of styles, songs, they come with a structure, and those help the artists with coming up with a conceptualization, with coming up a clear view on how we will structure the song. We also choose the right model, so we can switch in between, because other model gives other results. And it also asks you to come up with a description of a song. How would you like this, the song to sound like? So in this case, I took an example. The song is about a couple of bananas meeting on a sunny beach drinking a cocktail. The song is inspired by 90s dance music, and the song contains multiple drops, consists of heavy beats, and has a guitar riff solo. Now, I'm not a musician, but I only think of what I like to hear, and you know from what age I am, what age I most probably have from 90s music. But that's my part in the song. That's how I start directing it, the song. I want to help out, how I want to be creative and start creating my song. But then it's up to our agents. They start working. So we got our artist talking to the composer. Come up with a concept. Think of a theme. Think of a rhythm. What would be the melody? Having this input of two bananas on a beach, drinking a cocktail, and there must be a guitar riff in between, and etc. That's where actually the interaction starts with OpenAI. That's where we start setting up our chain, and our assistants take place. So they already have a particular role. So when we talk about an artist, then we have, you're a musical artist making electronic music with Sonic Pi. So our agents have a specific focus, specific task. They already know in what direction they are pointing and where they're trying to find a solution for. Whereas the composer is there to come up with an idea for a song, and this idea can be a theme, a melody, and a rhythm, and so on. Because we go further on, where we have a composer talking to our songwriter, based on the concept she just thought of, the theme, the melody, what would be, can you come up with some lyrics for the song? Can you come up with a nice song and write a song for me based on those input? Moving along, having those theme, having the rhythm, have an idea for the melody. Our composers start talking to the arrangers, start up a conversation on defining the structure of the song. Will it be, so we get the lyrics, so we most probably have a verse, a chorus, but we chose style rock, so it might be another structure. So that's when we're starting to define the segmentation, how the song will be structured. And then finally, during the design, we come up with the arrangement. Would it be nice hearing a piano or a guitar, or do we add some beats or a drum? That's where, that's the final phase of designing. So, putting that all together, we're ready to start creating the song. So we got our artist taking that all along, going back to our Sonic Pi coder and start saying, okay, this is the concept, this is the rhythm we defined, we have a structure, we have an idea on the instruments that we want to use. Now it's up to you, start writing me some code, start writing me a song based on that in Sonic Pi, so we can actually play the song. But as we all know, we write code, and code comes with bugs. Code doesn't always work directly. So we put in a file save, a security check. So we got the Sonic Pi coder who does ask to his reviewer, can you please check my code? Can you check if it's correct or not? And we got a reviewer agent actually going through the code, checking out if everything works. And that's about the part where actually the real magic starts happening. Because then we're going to start up a cycle in between our coder, our reviewer, but even you as an artist, you can also launch a playback of the song automatically, where your agent, your artist, will ask to you, how do you like the song? Do you want to improve something? Is there something you want to change? And you're in control on how many iterations, how many times you want to do this. So you can first let the agent do their work, start reviewing the code, having multiple iterations, checking and to come up with something that properly works. And then you can start hearing a playback, and you can give your own input. And based on that input, the reviewer, the code, Sonic Pi coder, will start correcting the song over again. Then we finally have a song. Let's start finalizing. So we go to song mixing. Song mixing involves mostly adding some beautiful fade in, fade outs, removing all the gaps which are in between, making sure that the length is correct, because it's based on beats per minute. So within Sonic Pi, that's how the coding works. So you need to make sure that it's also being adapted. And while you're seeing the conversations dropping by, you might have noticed somewhere in between. It doesn't necessarily, it gives you a lot of input to the agent, a lot of context, but it also provides some questions on how he wants to see the outcome. So in case you haven't noticed yet, but it comes in between, it always asks them to come in to provide a proper response in JSON with proper fields on how he wants to get a response of the agent. So we're moving along. Sorry. So song mixing, we're producing the song, and actual producing of the song means creating that final Ruby file, the Ruby file that contains the Sonic Pi code that can be played within Sonic Pi. Going along, we also want a recording, so we can go to the recording studio. We can actually make a WAV file, creating an actual song composition, so we can do a recording. It will also create some cover art. It will create a booklet, and a booklet means you get your cover, you get your lyrics, but you also have an idea on the prompt you used. It will also give you an idea on the structure that was used, all the arrangement that were used throughout the song, because you're an artist and you want to be able to replay it. You want to be in control, and afterwards, with the files created, you can still adjust. You're still in control of the song. You can still change anything you like. So it comes out with the booklet, and of course, a nice cover of our song. So in case if you didn't remember, we started with 2 bananas drinking cocktail on a beach, of course. So wrapping it all together, starting from CLI input, we go through the design phase where we come up with a theme, where we created the arrangement, the structure. We did some songwriting, where we actually created the song. So we developed the song with Sonic Pi. We moved over multiple iterations where we could review, as well as the agents could review the code. Went to the mastering phase, so leaving out all the gaps, making sure that intro, outro is well set up, that the duration of the song is correct, that everything is checked, and actually come out with a Ruby file output. Publishing phase, recording, cover art, and final booklet, providing us a nice song folder where we have the song, where we have the recording, where we have the Ruby file, and also a nice cover of for our booklet. So it might kept you thinking while we were doing this. We were having all those phases and those iterations back. Yeah, it might have reminded you of something else. In this case, software development cycle, where you also gather some requirements. You're doing an analysis. You come up with a design. You start implementing code. You start reviewing it, correcting the code. You test it. You correct your code. Going to a real deployment, like a recording of a song, and then you start to maintain it and get back to the requirements. Quite familiar, quite similar. So similar setups can be used, could be addressed also in those. So that's why it's that nice, that handy. It comes up where we're also tackling complex tasks where it can be reused as well. So let's have a quick look at the architecture. As MusicAgent is actually quite simple in setup. It uses a CLI to simply introduce commands to give instructions to the agents to modify the song. It launches a bunch of Python scripts, where at that point those multiple agents start to get into action and start actually composing the song, start creating your song. While doing those, everything is based on a multiple configuration file where we define the artist, the change, the different phases, and they start interacting with OpenAI. But also, as we want to have a playback of the song, we want to test the song, we want to make sure that the song works, because in the end it's still code, but also that it sounds right, that we can give some input as a user, as an artist. That's when we also start interacting with Sonic Pi using Open Sound Control. So, and of course, there's an interaction with the user, with the artist themselves, to make sure that if you think of, I don't like the bass, change it again, we are still able to do so. So that's a bit the complete process of MusicAgent, where in the end comes out again our Ruby file, our album cover, our booklet. So in practice, we have a base setup for MusicAgent. As I said, we have some configuration files where at one point you have your configuration of an artist. So this is completely adjustable. Everyone can change at their own needs, at their own wishes, at their own taste even. Because as you notice, it comes with even an artist styling, so you can give your own styling as an artist, and it will direct the agents when creating, for instance, the album cover. So in this case, I chose a retro and vintage using yellow, dark green, orange, as you might have noticed throughout the presentation. But it's also the point where we define our different agents. So we can define different roles, and it's completely flexible. We can change it at our own use, at our own wishes. So you can define an artist, a composer, but if you like to add some other roles, you're completely free. You can and even change the different type of roles. Of course, having those roles, you need to define also the prompting. You need to define the different phases. And when an artist is talking to a composer, or when a composer is talking to a Sonic Pi coder, you need to come up with the correct prompting. We need to ask the correct questions. Like in this case, this is an example of the songwriting where we ask for, okay, this is a theme, this is the melody, there's a rhythm. Now I want you to come up with some first lyrics and a structure based on this input. And finally, having all those different phases, we need to combine them. We need to define at what point will we address which phase, and in what order do they take place. It can be a simple conversation from a composer, from an artist to a composer, but as we saw earlier on, when a Sonic Pi coder and the review process will take a longer way. So then we're in a more complex phase with multiple iterations. Same applies to we as an artist, as a human, discussing with the Sonic Pi coder, reviewing the code, also contains multiple iterations. And we can play along with it. We can change the different orders, the different change for our own taste. So, basic setup, basic flow. We have the different configuration files. We have a role, we have the chains, and we have the phase. So, comes up with concept, initial coding, some code. So, as we saw earlier on, where, for instance, the concept is a simple conversation starting, a simple phase starting a conversation in between the artist and the composer. But whereas for the song code review, it gets a bit more complicated, where you have multiple configurable iterations in between code review and code modifications. But we can go one step further. So as you noticed, we have multiple types of configuration, and that's not the end, because it's simply JSON configuration. We can play as much as we like with it. It only has an impact on your chain, on the duration of your chain, the long it will take to create one song. And in the end, you can still change or adapt it. So it could be simply creating art. It could also be having the playback, including the recording. It's all configurable. So making it, taking it one step further, if we add, for instance, human code review, that means that we'll be sending open sound control commands to Sonic Pi. It will play back the song, will enable us to hear the song. So we can also give our own input to the agent. So we can tell, I don't really like this one. Oh, this is more of an eclectic song. That is not the sound of the kind of song that I had in mind. I was expecting something else, so please adjust it. Or in this case, I'm missing an extra instrument. Maybe add a bridge after the second chorus. And then the review gets passed to the agent, and the code gets modified. Also over multiple iterations, because we want to hear that the new result is also fine. We want to make sure that it's correctly understood what I asked them, what I reviewed to the agent. Same applies for song recording. We'll be using again OSC commands to order a playback in Sonic Pi, enabling us to create a new recording, a WAV recording. So, enough said. I think it's time for a demo to show some code and to play some music, so we can wake up again, as it's early in the morning still. So let me quickly use. So here we're in the MusicAgent source code. So as you might notice, it's quite light in terms of coding. Also in terms of setup, the only thing you need to have is having Sonic Pi installed. You need to have Python installed and an API connection. API connection, for instance, in this case, OpenAPI OpenAI I used. Okay, so how do we create the song? So purely CLI, we run the script. We get to choose the model. In this case, I'm going to select the 4.0 Mini. I'm going to have to choose a configuration. That's an interesting part. So earlier on, I was showing you the different configurations. So all configurations can be found in the config folder. So you'll notice by default, there are already different configurations set up, which can be used from a basic configuration where we'll find, as I've shown, the artist name, the styling, but also the different roles are defined. So in a basic configuration, you'll find back all the roles in the simple phase as defined earlier on. If we go to the full one, you'll notice it also contains additional roles like a publisher, like a normally the Sonic Pi coder, the recording are included in there. That's one thing. So we also said we need to define the phase. Again, in basic phase configuration, you'll find back the prompts, the different steps being taken into account in the creation of the song, like the conceptualization. But of course, you'll notice that we have the segmentation, so creating the structure, the arrangements, which instruments will we be playing, where we also define the input and output that needs to come out of those conversations. So from initial song coding to code review and so on and so on. While we go to the more full configuration, there's also the human input normally that we should. So we got, for instance, human review, which is included. And actually, you can just copy paste the folder and start chaining yourself, changing the roles, changing the different phases. Because in the chain phase, that's where we define. So here you can define the multiple iterations you want in between review, song. If you want to include an album cover or not, you can just drop it out. Or within the art configuration, it just simply creates an album cover. So at what point you created a song, you created a cover, it's not the one you like, you can just simply relaunch the script and create your own cover. So for the time being, I'll choose the first configuration, so the simple one, the basic one, because in amount of time, it only takes a couple of minutes to run. So results can change. The longer you take, the longer you let it run, of course, the better results you'll get. If you run the third or the fourth configuration, so with evaluation, with playback in Sonic Pi, of course, it will give a better result because you get to hear the song, you get to modify it, you get to review it, and in the end, it will be a better result. So, but for now, for the time being, just for the terms of demo, I'm just quickly gonna run it so you can get a view of it. So let's enter a name for the song. I will call it Devox 2024. Any wishes for the kind of style you prefer? So it's asking you for rock, electro, drum and bass. Any preferences? Do we have metal? Did I include metal? We got heavy metal. Now, in my experience with Sonic Pi, if we introduce this style, it can come quickly quite eclectic. It helps when having multiple iterations when doing so, but let's give it a try. Let's do rock. So again, think of it, even though if you chose heavy metal, it is Sonic Pi. We're creating electronical music. So it will try to replicate, it will try to simulate the type of music in terms of structure, in terms of styling, but it still is electronical music. So let's add a description of the song. Any thoughts, any ideas? What was it? A song about the AI gods, and we're praying for them to make a nice song. Okay. Any input on how the song should look like, should sound like? Well, existing bands they have a certain style which can be described. So based on that description, it can come up with something similar. But in the end, it's not a duplication. It's not a copy. So it's never a copy. But of course, you could say, okay, make a song like the Beatles, and it will have some idea on what a Beatles song would sound like. But again, we're discussing with LLMs. We're not creating a text-to-speech. It's not based on any sound model. So, but that's feasible. Yeah. But we have to be careful not duplicating exactly the same song. But that will never be the case in this one. Do we add some beats or riffs or guitars? Any ideas? Any wishes? You can just play along. So maybe sax. Saxophone. Okay. Yeah, an electrical guitar solo would be nice. Oops. I'm even making typos, but that's actually not that worse. That you can cope with it. An electrical guitar solo would be nice as well. Okay. So let's launch it. So it started conceptualization. Different phases are starting on. Again, this is the shortest track I've chosen, so even for me it will be a big surprise what comes out, if it works or not, because mostly if we take it this short, it doesn't always work because, as we know, sometimes it tends to hallucinate. So the longer we direct in the right direction, the better results we get out of it. So while he's onto it, while they're creating the song, let's give a first example on how things will come out. So we have so MusicAgent comes with a song directory, where, for instance, let's take this one. So actually, I had a talk on Tuesday where we created this song. It came out during the demo, and it gave an error. But actually, the error was that they used a wrong chord. It used the C major, where the C major wasn't recognized in correct Sonic Pi code. So in between, I corrected it. Just to give you an idea on how it came out. So we got the booklet with the album cover, we have the lyrics to the song, and we have the song parameters. So last Tuesday, they said, okay, they wanted to have it with a French touch, some classical melodical patterns in the background, and a punk rock interlude. It actually created the Ruby file, so this is the Sonic Pi Ruby file, and then it sounded a bit like, where is it? So this is the one we created on Tuesday. So the song, it only took 5 minutes to create, gave one error, we quickly could correct it, and that's how it came out. Okay. In the meantime, let's check. So in the meantime, the agents are reviewing the code, making modifications to the code, and they're still ongoing to work. So while we're into the folder, you also notice we have the full log, so we can track back the different prompts, how we made a conversation in between agents. We can see how the prompt changed, how the outcome changed along the way, and also the different iterations on the Sonic Pi code. So it might be that another, while you as well are reviewing the song, it could be that you liked another version better, so you can still trace it back and still get back to it. So within the presentation, I show another example, which was the banana song. So for this one, I took a longer iteration, which also played, and that comes out. So remember, we asked some bananas drinking cocktail on the beach, and that one came out like this. Notice also some synths, some samples being used. Now, in the end, it is still code. So when we ever see this type of drum beat, or if we see the cymbal being used, we can still change it. So if we hear something we don't like, in the end, it's code. We know how to develop, how to code, so we are still in control of our song. Now, while showing the banana song, what is also nice to show is how he creates the song structure. So you can find back also the song structure within the code, where Sonic Pi wasn't initially meant to work that way. So it's kind of nice how he comes up with solutions to create the song. Like for instance, the other song I showed, where he also creates that structure with an intro, a verse, a chorus, and he does that in all different types of ways. He can be using live loops where he sings them, where he also, or by simply using the amount of beats and counting the beats to start a new part of the song, or segment them. So also quite nice to see how that comes along. So now it ended. So now I'm as curious as you are, most probably, so I hope it works. We'll see how it comes out, because it will be as much as a surprise for me as for you. So again, it created an intro, a verse, chorus. Okay, let's check. And there it crashes. Okay. So again, okay, it's using some. Let's correct. And then it will start normally. Okay. So in this case, I only use like 2 or 3 iterations in the review of the song. And what mostly, the biggest reason why do we have a compilation failure is that I didn't use the Sonic Pi integration. Why? Because it takes a lot longer. Because at that point, it's really it playbacks the song in Sonic Pi. If it crashes immediately, you'll get an immediate answer. But if the song plays, you have to wait the song to play to correctly hear the song, so you can give the inputs. That's the reason why I didn't include it in this demo. But it would definitely help you to get better results out of it, of course. Okay. That being said, let's get back to the presentation. What does the cover look like? Ah, nice one. Yeah, thank you. So the cover, oh, we got some heavy metal. Let me get it bigger. This is our cover. So we have the sax. So yeah, I'm missing the violin a bit, but okay. But something we can start with. But of course, as I shown, there's also we can use the other configuration. We can also start creating new art. We can launch it all over again with the same prompt, simply for creating new album cover. So, getting back to the presentation. A final remark I wanted to make, and if it's not even related to MusicAgent, you can also use it when thinking of the full, the example I gave of the software development cycle. More than over a year ago, 2 years ago, when ChatGPT 3 came out, people started using it. People started also using to create a new song. In that case, at that point, it was creating song lyrics. And they started mailing to Nick Cave from Nick Cave and the Bad Seeds. If you haven't seen him yet, you must definitely do so. I think he's by the end of October and also playing in Sportpaleis, very near. He received lots of mails, people saying, okay, Nick, I wrote a song like you did. What do you think of my song? And I created with ChatGPT. And there was a lot of fuss about, and Nick Cave gave a reaction. He told, I'm going to read it out loud, "It's a blood and guts business here at my desk that requires something of me to initiate the new and fresh idea. And in the end, it requires my humaneness." And if we think it over, when we're working with AI, whether we're developing, whether we're writing a mail, whether we're creating music, we don't want it to become average. We still need to have this holistic view of creating, of processing, of combining everything all together. And whenever we're developing, we're creating some code, we're creating some tests for it, it's a full cycle we need to take into account. And that's always something we can do as humans. When we look at a song, we give the first introduction, we give a first idea of a song, the first part of the concept, but also we, as human only, can have a the correct feeling. We know when something is nice or not nice, how it feels like, because it's also part of taste, and that's where we come in as human. Okay, I need to wrap up. Quickly gonna back. If you want to check out the code, if you want to test it out yourself, there's the record. Okay, thank you all for. Sorry.
All systems are nominal. Initialize Genesis